Did you just get a Raspberry Pi 5 and are confused how to do GPIO-based UART serial connections? Yeah, I was too. And today I'm going to show you how to establish that serial connection using GPIO on the Raspberry 5 without needing a dedicated UART serial cable. All while going over how to use the Flipper Zero as a UART to USB debug bridge. Let's go engineer some stuff. Now, thanks to my awesome art skills, let's take a look at our Flipper Zero to Raspberry Pi pinout connection diagram. This will give us an idea of what wires need to go to where. So starting off, we have pin 13 TX on the Flipper Zero, going to pin 10 RXD, our receive, which is GPIO 15 of the Raspberry Pi. Next up, we've got pin 14 of the Flipper Zero, the RX, going to pin 8 TXD, the transmit, GPIO pin 14 of the Raspberry Pi. So lastly, but just as important for any of this to work, is we need to go for pin 18 on the Flipper Zero to pin 6, which is a ground-to-ground connection. Once on the Raspberry Pi, if we type Pinout, we can see a cool representation of the Raspberry Pi's pins. If we scroll up to the top, we can see Raspberry Pi 5B revision 1.1. And now if we go down here to actually look at our pinouts, we can see that we'll be using the ground, GPIO 14, GPIO 15, and these all correspond to pins 6, 8, and 10 like we talked about in the diagram previously. Now, a word of warning. As the text says, do not enable UART this way. I'm just showing this as a demo when you go into Raspberry config, what happens. Ordinarily, you'd go into the menu and you would enable the serial console this way. For our example, we want to make sure we don't do that because this way will enable the 3-pin debug dedicated connector that we aren't using for this. Now, if we cat the output of boot firmware config.txt and we come to the bottom, we can see at the bottom we need to add a DT param UART0 console. This will redirect the serial output that we need to those GPIO pins instead of going through the default 3-pin header. Likewise, if we look at ls dev tt ama 0, this will be the default device that we need to redirect in our next step to CMD line to use the console. The last step of our config is going to be to take a look at cat boot firmware cmd line.txt. As we can see, we've added console tty am0 and 115200. These are important kernel parameters for the Raspberry Pi on boot, as it will tell it what serial device we want to use for our UART, and it will tell us what baud rate we're going to use. Since that wraps up the Raspberry Pi side of our config, we can now move on to the exciting Flipper Zero part of the config. On the Flipper Zero, to access the USB-UART stuff, we need to go to the GPIO section, then the USB-UART bridge, and now once we're here, if we hit the left button on the pad, we can config. USB channel should be set to 0, and we want to set our baud rate to 115200 to match what we have in the Raspberry Pi config, and make sure our UART pins are set to 13 and 14 to match our pinout diagram from earlier. Before we can connect to the Flipper Zero UART bridge, we want to figure out which communications port it's going to use. If we go down to our ports, COM, and LPT, we should see it says USB serial device COM3. This will tell us what we need to connect to in Putty. From the software side, we'll be using Putty to connect. We're going to want to switch to a serial connection type, and then we're going to hit COM3, and we're going to enter a baud rate of 115200, and then we're going to hit open. Now, with our Putty session open, if I press the enter key, I'll be presented with the login prompt. From here, I'm going to log in as the root user, enter my root password, and you can see we're successfully logged into our Raspberry Pi. If I exit back out, it'll take me back into the login prompt. I can enter SJR as my non-root user, put in my password, and we'll be once again logged into the Raspberry Pi. Now what's cool, if I type sudo reboot and issue the reboot command and give it a second, we'll start to see those UART serial connection messages logged. Unfortunately, because we're not using the main 3-pin connector dedicated UART output, we don't see the EEPROM messages, but it's still cool to have the serial console, and it's still cool to be able to see some of the debug messages. Well, it may not be the most cinematic or in focus footage because I was trying to film this with one hand while typing on my Raspberry Pi. We can see that the TX and RX counters are incrementing on our Flipper Zero. Especially notice when I hit the reboot command from our Putty session, there's a huge jump in the number of transmit and receive bytes. This is an excellent sign for us that the transmit and receive are working as expected, and we're able to send the data we want through the UART serial console, all while bridged through the Flipper Zero. Hopefully this video cleared up any confusion you might have had on how to establish a UART serial connection with the GPIO pins on the Raspberry Pi 5. And as always, thank you for watching. Comment down below if you have any questions you'd like me to answer, and I'll see you all in the next one.